The smartest engineers on Earth built this thing, and they cannot fully tell you why it does what it does. You type a question. A few 100 billion calculations later, an answer appears. It feels like the machine understood you. It didn't. There is no understanding in there, there's something stranger. And once you see it, you can't unsee it. For the next 20 minutes, you're looking inside the box, not the marketing version, the real machine, the neuron, the network, the training. The exact moment a pile of numbers starts to sound like a mind. By the end, you'll understand AI better than almost everyone who uses it every day, and you'll know why its own creators call the middle of it a black box. And this isn't academic. You're about to hand more and more of your thinking to this thing, your writing, your research, your decisions. Knowing what's really inside it is the difference between using a tool and being quietly used by one. Start with the smallest piece, one artificial neuron. And forget the brain comparisons for a second, they'll only slow you down. A neuron here is just a tiny decision maker. It takes in a few numbers, weighs each one, adds them up, and decides whether to fire. Picture a bouncer at a door. Each input is someone arguing to get in. Some arguments carry more weight than others. That's literally what a weight is. The bouncer sums up the weighted arguments. If the total crosses a line, the door opens, a 1. If it falls short, the door stays shut, a 0. That summing and deciding step has a name, an activation. It's what lets a neuron say not just yes or no, but how strongly. And that little non-linear kink, that decision, is the secret. Without it, stacking neurons would just be fancy addition. With it, the network can bend, curve, and capture patterns that a straight line never could. That's the whole neuron. On its own, almost useless. One bouncer can't recognize your face or write a sentence. But here's the question that breaks it open. What happens when you stack millions of these bouncers and let them feed into each other? That's where simple ends. Stack the neurons into layers. Say you feed in an image, just raw pixels, just numbers. The first layer hunts for the tiniest things. One neuron fires when it spots an edge, another when it sees a patch of a certain color. On their own, meaningless, now the trick. The next layer doesn't look at the image at all. It looks at what the first layer decided. Edges and curves combine into a shape. The layer after that combines shapes into an eye, a wheel, a letter. Layer by layer, raw numbers climb into meaning. And nobody ever programmed the rule, this is an eye. The network assembled that idea by itself, from the bottom up. Picture it recognizing a face. The bottom layers see only light and dark dots. A few layers up, those become edges and gradients. Higher still, edges become an eyebrow, a nostril, the corner of a mouth. At the very top, all of it snaps together into one decision. This is a person, and it's this person. And the word for stacking many of these layers, going deep, is exactly where the phrase deep learning comes from. The depth is the layers. Sit with how strange that is. You didn't write rules. You built a structure capable of finding its own rules, which lands you on the obvious question, how does a pile of random connections learn anything at all? Because at the start, it knows nothing. Worse than nothing. At the start, it is confidently, completely wrong. Here's how it learns, and here's the first uncomfortable truth. A fresh network is just random numbers. You show it a photo of a cat, it guesses dog. Confidently, it has no idea what a cat even is. So you do the one thing you can, you measure exactly how wrong it was. One number. The error. Then the machine runs that error backwards through every single connection, asking a brutal little question at each one. Did you push the answer toward right or toward wrong? Every weight gets nudged a hair in the direction that would have been less wrong. That process has a name: backpropagation. It is the engine underneath all of modern AI. Now do that again and again, across millions of images, billions of times. Cat, adjust, no human checks the individual nudges. There are far too many. The system tunes itself by being wrong over and over until it's mostly right. And this is why these systems are so hungry for data. A child learns what a dog is from a handful of dogs. The network needs thousands, sometimes millions, because it has no head start, no instinct, no body, no life. All it has is examples. The data isn't a detail here. The data is the teacher. Whatever is in it, the network absorbs. Whatever is missing, the network is blind to. And here's the part to hold on to. Nobody chose the final settings. There are billions of them. We started the process and fed it data. We did not write the answer. The knowledge the network ends up with is something it found, not something we put there. Remember that. It's the root of everything unsettling that comes later. For a while, these networks were useful but narrow, good at one job, like spotting a face or reading a number. Then researchers tried something almost dumb in its simplicity. They made them bigger. More neurons, more layers, more connections to tune, more data to learn from, more raw computing power thrown at the training. Those tunable connections have a name: parameters. Early networks had thousands. Today's biggest models have hundreds of billions. And as they crossed certain sizes, something nobody fully predicted happened. New abilities appeared that weren't there before. The model could suddenly translate or summarize or reason through a problem step by step. No one added a translation module, it simply emerged from scale. And this scale isn't cheap. Training one of these large models can mean thousands of specialized chips running for weeks, burning through electricity and money on a scale that only a handful of companies can afford. That's part of why so much of modern AI is concentrated in so few hands. The recipe is public, but the kitchen costs a fortune. That word, emerged, should make you slightly uneasy. And it's a clue to where we're heading. Because the people building these systems were now watching abilities show up that they hadn't designed and couldn't fully explain. They had the recipe. They didn't have the full map of what the recipe would produce. Hold that thought. We still have to explain the hardest jump of all, from recognizing pictures to actually using language. For years, this worked best on images and numbers. Language was the wall. Words aren't pixels, meaning lives in order, in context, in what was said 3 sentences ago. So researchers reframed the entire problem. They turned language into a prediction game. First, chop the text into tokens, not quite words, more like fragments. Talking might become talk and ing. Every token gets turned into a number. And now the whole impossible problem of language collapses into one question the machine asks endlessly. Given everything so far, what token comes next? That, at its core, is all a large language model does. It is autocomplete that swallowed a huge slice of the internet. You give it the capital of France is, and it does not look up a fact in a database. It calculates that Paris is the most probable next token and says it. Right answer. Zero knowledge. Keep that gap in mind, because it quietly explains almost everything that goes wrong later. But there's a deeper layer to how it handles those tokens, and it's genuinely beautiful. Every token gets placed as a point in a vast invisible space, hundreds of dimensions, where meaning becomes direction and distance. Words that are alike land close together. King sits near queen, Paris near France. And here's the part that stuns people the first time. In that space, you can do arithmetic with meaning. Take the point for king, subtract man, add woman, and you land almost exactly on queen. The machine never read a definition of royalty or gender. It absorbed the relationships from raw text until meaning itself turned into geometry. Nobody designed that map. It emerged, again, from the data. But predicting the next word well is fiendishly hard because meaning depends on what you pay attention to. Read this sentence: the trophy didn't fit in the case because it was too big. What does it mean, the trophy, or the case? The trophy. You knew instantly. The machine has to learn to know that. The breakthrough that made today's AI possible has a name: the transformer. Its core trick is called attention. For every word, the model asks, which other words should I be looking at right now? It draws weighted lines across the whole sentence, the whole page, connecting it back to trophy, a pronoun to its owner, a question to its subject. It learns what to focus on. And it does this in layers, just like before. One layer of attention might track grammar, which word is the subject, which is the verb. Another might track topic. Another, tone. Stack dozens of these, and the model builds a layered, shifting sense of what a passage actually means, not just what words it contains. It's reading context the way you do without noticing, except it learned every bit of it from patterns, not from living. Do that across billions of examples, with hundreds of billions of those self-tuned parameters, and something eerie emerges. The model starts producing language that holds together: grammar, logic, things that look like reasoning. This is the moment numbers start to sound like a mind, and this is the exact moment you should get suspicious. Because the closer it gets to sounding human, the easier it is to forget what's actually underneath. Here's what is actually happening, and what isn't. The model does not know that Paris is in France. It has no concept of France, no mental map, no mental anything. What it has is a staggeringly precise statistical sense of which symbols tend to follow which other symbols. It is the most sophisticated pattern matcher ever built, wearing the mask of comprehension. This is why it hallucinates. Ask it something it has no strong pattern for, and it does not stop and say, "I don't know." That isn't how the machine works. It generates the most plausible sounding next tokens, and plausible is not the same as true. A confident, fluent, completely invented answer isn't a glitch. It's the mechanism doing exactly what it was built to do: continue the text convincingly. People have watched these models cite court cases that never existed, name books no one ever wrote, invent quotes in a real person's voice. Not because the machine is lying, it has no concept of a lie. It's doing the one thing it knows, producing text that fits the shape of a real answer. The format is perfect. The facts are smoke. And the more confident it sounds, the more careful you have to be. And the bias people worry about? It learned that from us, from oceans of human writing. Every pattern in that text, the brilliance and the prejudice alike, got absorbed into those billions of weights. The machine is a mirror. It reflects the data it was fed, flaws and all. It didn't decide to be biased. It learned us a little too faithfully. Which brings you back to where you started. Those billions of self-tuned weights, no one can read them like lines of code. You cannot open the file and find the spot that decides what the model believes about a topic. The knowledge isn't stored in a place, it's smeared across the entire network as numbers. That is the black box. We can see what goes in and what comes out. The middle is, honestly, still being mapped by the same people who built it. There's a whole field racing to crack this open. It's called interpretability, and its goal is to reach inside the box and figure out what individual parts of the model are actually doing. They're making real progress. But be clear about the order of events. We built these systems first. We are reverse engineering how they work second. That's backwards from almost everything else humans construct, and it's worth sitting with. So what do you actually do with this? 3 things. Treat it like a brilliant, fast intern, not an oracle. It is fluent, tireless, and fully capable of being confidently wrong. Check anything that matters before you trust it, and understand its real power. It isn't truth, it's fluency. Use it where fluency wins. Drafting, explaining, brainstorming, translating, and verify wherever the facts are non-negotiable. You came in thinking AI might understand you. Now you know the stranger truth. It doesn't understand a single thing, and it's still going to reshape how you work, learn, and decide. The people who build it are racing to understand their own creation. The least you can do is not be fooled by the mask. If this rewired how you see these tools, subscribe. Every video here takes one thing the whole world is using blindly and shows you the machine underneath. 20 minutes. No fluff. See you in the next one.